obviously when we think about it makes sense that we're talking about estrogen signaling in the context of things like pregnancy and early development. But of course, all of these hormones, estrogens, androgens, everything's in males and females, just, it's in different amounts. There's different patterns of fluctuation at different periods of the life cycle. We talked about pregnancy and fetal development a little bit, but I want to think about how these things can affect males versus females now. And it's natural to imagine that the effects would be quite different because the pattern of estrogen receptors and other things is going to be distinct in males versus females. What do we know about effects in males versus females for these xenoestrogens like BPA?
Hmm. There is sex differences. This is true. I would say for BPA and yeah, the experiment that have been done in the past uh, in terms of glucose homeostasis or obesity, uh, I think the effect, at least with BPA, is more in males than in females. It seems that females are protected, but the studies were not really designed to study different in sex. But new studies have been done, for instance, with dioxins, and it is not a xenoestrogen, but it's acting through the aryl hydrocarbon receptor, which is another nuclear receptor. And these are results from Jennifer Bruin laboratory in Carleton University in Canada. And they show very well how the phenotype in terms of glucose homeostasis is different between uh, males and females. And they designed the study to follow males and females. And it seems that in the case of dioxins, uh, the action is mostly in females. They have a more dramatic phenotype than males
Yeah.
actually.
And I guess
Yeah,
I
yeah,
guess on a very basic fundamental level, we would expect there to be a lot of sex differences when it comes to endocrine disruptors because the differences between the difference between a male and female comes from it has an endocrine origin, right? It's the
yeah,
endocrine system is
yeah,
actually
yeah,
sculpting the bodies differently and making them
yeah,
differentially sensitive to all of these
yeah,
hormones. So we should expect that, I think, right?
yeah. Indeed. I mean, for instance, in our experiments, we have never seen that phenotype of insulin resistance, glucose intolerance, or hyperinsulinemia in females.
Hmm.
So this is why we
In non-pregnant
started to do
females.
it in non-pregnant females, of course. I mean, in offsprings, I
I see.
meant, or in adults
I see.
when we treat
So,
it.
so you've got results where
Um,
BPA exposure in adult males and adult
Males.
non-pregnant females,
Yeah,
you get bad effects in the males that you don't see in the females so much.
we don't see in the females. We didn't publish in the females. We just didn't see anything and just mention a brief phrase, at that time. That was
Wow.
years ago. But other people have done later, these experiments. And it seems that in most of the cases, in offsprings, uh, the phenotype is in males and not in females. So
Yeah.
that has been done with BPA by the group of Rebecca Simons in the
Yeah.
Penn University there
Yeah.
in the States recently. Yeah, and in vitro cells, we have more or less the same. If we measure, for instance, apoptosis in the beta cells, we get with bisphenol A, and we don't get apoptosis with estradiol.
Hmm.
And indeed, estradiol protects from apoptosis by BPA produces apoptosis.
Interesting.
And they both use estrogen receptors to do this effect. So,
Wow. So obviously, yeah, you get different effects in males and females. Not too surprising. When we look at, stepping back for a minute, when we look at our modern environment, it seems to clearly be net estrogenic for males and females. I know that at least in the U.S., the age of puberty keeps getting earlier and earlier for females, and obviously in
mhm.
males, it's quite clear. Testosterone levels keep going down, fertility levels keep going down, sperm counts, et cetera, et cetera. Why is it? So we hear a lot these days about endocrine disruptors and xenoestrogens. We hear a lot about exogenous estrogen based endocrine disruptors. I don't hear a lot about xenoandrogens. Is there something? Why is it that there seem
Mm.
to be so many exogenous estrogens but not androgens. Is that actually true, or is there a reason for that?
I, I think the reason is that mostly estrogen has been studied.
Okay.
And for instance, the effect of some of these chemicals on androgen receptor is like opposite, is like antagonizing
I
uh,
see.
the androgenic effect. For instance, phthalates is a classical example since the 90s that they act as anti-androgenic uh, uh, chemicals.
I see.
And so they, let's say, decrease the response to androgens. Uh, so that's the point. As far as I know, yeah, I think estrogen receptors are the most studied, very likely because they were the first receptors
Yeah.
to see an effect, and
I see. But
you
for
know,
so basically the estrogen receptor and xenoestrogens, they might just be more studied, which is why we
yeah,
so a lot of
yeah,
this could be an artifact of where we're focusing our research energy. But the environment still does clearly seem to be net estrogenic. And at least what you're saying when it comes to phthalates is that, even though they're not estrogen disruptors like BPA, they have anti-androgenic effects.
yes, indeed, they do, and we know some of these chemicals they also affect uh, thyroid signaling,
Mm-hmm.
so they can perhaps not directly affecting the thyroid hormone receptors, but other enzymes that produce thyroid hormone.
Yeah.
And we know that there are chemicals that can also interact with other nuclear receptors, such as PPR gamma, where tributyltin is one of the main examples, I would say, is an obesogen as well, and acts as an agonist of PPR gamma.
Mm-hmm.
And yeah, there are dioxin, as I said, through the aryl hydrocarbon receptor, uh, etc. So,
Yeah. So two of these other endocrine disruptors you've mentioned, dioxins and phthalates, where do those come from in the environment?
well, dioxin is a byproduct of industrial, uh, 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 when you burn paper or plastics or
Mm,
whatever, and you produce these dioxins. Uh, so it's an industrial byproduct, actually. And phthalates are in plastics.
it's another microplastic.
It's another microplastic, and I mean it's another chemical in plastics. So phthalates are plasticizers, and there are also in many cosmetics.
So people are
Uh,
putting them onto their skin on purpose.
yeah, yeah. I mean, it's an stabilizes perfumes, for instance.
Oh, so you could
Uh,
breathe it in. You could literally breathe it in.
yeah, yeah. That's how it is. Yeah, and yeah, there are really many of them of phthalates around, and the other one that is really widespread and is a problem are perfluorinated compounds,
Mm,
which are persistent. They're very difficult to metabolize. They're very difficult
I
to get
see.
rid of
So
them.
they don't like break
Uh,
down. They don't get excreted
Not
easily.
at all. So we don't know that there is not much about uh, whether they work through nuclear receptors or not. There are some papers say yes, others say no. But these perfluorinated compounds are a real problem, and they are also involved
Mm,
in altering our metabolism. So they
mhm.
produce obesity and diabetes as well.
Yeah.